Thank you for our second talk of the day. This is Mauro. He's going to be talking about owner GlusterVS. Make sure you ask him about the exploit he has.
Hey, how are you? Well, this is a talk. It's a really beginner-friendly talk. It's about exploiting Gluster CVE-2018-1088. It's an authenticated access to every shared storage. This is a talk that I wrote having in mind for those who are new to both worlds, exploit writing and data duplication, in fact. So the entry point for many people into the world of data duplication is Gluster. And I also found that it was really easy to write an exploit for this CVI, so I wanted to share it to everyone who is interested in writing exploits in the future. I want to ask for your pardon in advance for my pronunciation. Might not be the best, so if something is not understood, just raise your hand and I'll try to repeat it. So, let's start. A brief introduction of who am I and what I'm doing. I'm from Argentina. I was born in the 90s. I worked all my life for government office. I own a really small company related to InfoSec in Argentina. And well, let's get going. For this talk, I wanted to build a lab on virtual machines, but I decided Docker because a recommendation from a friend. So anybody here uses Docker? Fine. For the rest who doesn't, it's really easygoing. It's really easy to understand. This talk, it's mainly a hands-on lab. So I understand many of you won't want to connect to the Wi-Fi network. Many of you won't feel comfortable downloading an exploit from a repo. Most of you won't feel comfortable using Docker here in this environment. So it's nice if you don't want to follow it, you can download it later. I try to follow that lab here like a live demo. So, okay. A quick start on Gluster for everybody who doesn't use it. Gluster is a scalable network file system. You can use any hardware, any cheap hardware you have to run it. It's, as I said before, it's a really good starting point for those interested in data duplication. You can duplicate almost any data. We have almost any data on any hardware, I mean. We have succeeded using it on really, really humble hardware, Raspberry Pis and the like, all laptops, and so. And even we have used some USB drives to clone, and it worked like a charm. It was acquired by Red Hat in 2011, but it's also available in the free world as an open source tool. So, as I was saying before, anything can run Gluster. It's really hard to see something that doesn't work with it. Call it FreeBSD, NetBSD, OpenBSD, wherever, even Raspbian. Anything you want can run it. In this talk, we'll set up Gluster as a simple replication service. We won't enter into that hassle of configuring complex things. The bug itself, the vulnerability, it's really, really silly, in fact. So we will build a simple lab, nothing complex. Our minimalistic setup will have 2 Gluster nodes, a volume for each node, and a single brick for each volume, and a bunch of test files. What does a node mean? Any server or computer that holds one or more bricks. The bricks are the basic unit of storage in Gluster. And a volume, it's a logical collection of those. Every file resides inside bricks. You can think of them like a sort of shared directories. I know it's not the exact definition, but it's for having a simple idea of this. Bricks compose volumes. All operations will occur at node level and will propagate accordingly. This illustrates basically everything I said before. You have the mount point on your operating system, the replicated volume, and the files on the bricks. A quick start on Docker for those who haven't used it before. Docker is the company driving the container movement. A container platform provides all the pieces an enterprise operation requires, including security, governance, automation, support, atomization, and certification. This is the definition provided by Docker itself. Let's suppose we have virtual machines. You can have an app like, okay, I will separate them in a VM for the app, a VM for the database, and if you want, a VM for the file systems, if you want. Containers are different. As they are oriented for microservices, they made the target is to have a minimal functional unit. On a container-based infrastructure, your app, the same as before, might look like this. A backend app, just you'll have your custom binaries, your custom libraries, and your app. Nothing else. The web server, you might have a container for Apache, for Nginx, for whatever you want. And the DB container might have just a DB engine. And even it might not hold the databases itself, the data files. Here we have a comparison. As you may see, you're just using your custom things, your custom application, your custom binaries, your custom libraries on your container. Everything else, the user land, is shared across all the containers. Okay, a common question is, where are my configuration files? We won't use them in this case, but it's a thing that always troubled me when I was learning Docker. If you follow the best practices, you will store them in an external volume. And you can even share all your config files across all your containers. So you can have a better control of your configuration files. Say, okay, this instance is configured that way. Okay, every instance will be following that policy, if we want to call it like that. Okay, the OS, Docker uses runc. You might remember as lib container, which runs in the same operating systems. They have also it features layered file systems. Okay, the binaries, even if you're using custom ones, the classic unique userland is shared and available along all the containers. Okay, we'll build our hands-on lab. Once again, I know you may not be comfortable doing this right now, so okay, no problem. I'll have a live demo here. The Docker containers. You can easily install our lab doing install apt install docker, git, and GlusterFS client on that specific version. This obviously works for JOM or DNF-based distros, so no problem. Even for FreeBSD. Okay, I have set up my repo, GEVAUDAN, on github.com. You can simply build the image, tag it whatever you want. The tag is the name you're giving to the image itself, GEVAUDAN Gluster. It should be run in a privileged environment because Gluster requires to do so. You can run most of the images or Docker files around there without any privileged user. So this will give us an instance ID. Then you can use it to identify that container. The magic of Docker is that you can run as many instances as you like, or as you can, of the same product. So if we run this command, docker run privileged true, twice, we will have 2 instances of the lab. If we run it 3 times, we have 3 instances, and so on. This is really useful when you need to have, obviously, configuring something at top, like a failover or like a distribution. Using the command docker ps, you can see our lab. They're both running with different IDs, obviously, and what they are doing. I would like to share with you the Docker file so you can see how easy it is to build. Sorry. This is our Docker file. As you might see, this is the base. From Debian Stretch Slim, so we are pulling an already made image. We just run app update, app install, without prompting, GlusterFS server, the vulnerable version, 3881. We purge everything that we don't need. Docker points to microservices, so we need to have a minimal setup of every container. And these are the custom configurations to make the cluster volume directory, to have it absolute access for this test, to run Gluster, and to change the PS1 just to look like the one I showed here. Sorry. The PS1 thing is something aesthetic, just to have that whale here. Okay, as you might see, we have both containers running. We can enter the containers just doing that command, docker exec ti. It's for executing on an interactive way, bash. So we have the IP address of every container. How do we set up Gluster for this? As we have two containers, we'll call them server A and server B. We can enter server A and issue the following commands. Gluster peer prove server B. This is for telling the server A, hey, recognize that one, check if that one is running a Gluster instance and pair with it. Gluster peer status, and on the other side too, Gluster peer status. We have something like this. As you may see, prove, yeah, it's working. Status, yeah, I have a peer. This is my new peer. From the other side, we don't have to pair it again. Status, number of peers 1, and a unique ID. So, they are recognized as partners. Remember, they are vulnerable versions. They are already patched up, so don't keep these containers for anything more than testing. Okay, let's keep going. We have to create volumes for this. Gluster volume create DEFCON vol replica 2 transport TCP where server A on this mount point. Remember, in the Docker file we stated to create this mount point. It won't create it if it doesn't exist. Then on server A, again, Gluster volume start DEFCON vol. So start this volume. And Gluster volume info from the other side, just to check if it found it. You might see these are the output from the commands. Success, start the volume, we store it. And this one, without further interaction, knows where it is located and starts to replicate here. This lab is already set up for replicating. So on a client, on our desktop, laptop, or whatever we are using outside the Docker, we make our mount point, GEVAUDAN POC. Sudo mount GlusterFS, where on server A, DEFCON vol, as you might see, we skipped any path, just DEFCON vol. Where mount it here, where we just make that there, mount GEVAUDAN POC. This will mount our recently created volume. Then on our desktop, echo data duplication village to mount GEVAUDAN banner.dat. This will make the replication to happen. So we'll cut the file on both nodes and check it has replicated, in fact. As you may see, here we create the file, cut, work it, cut, work it. No further interaction. It's really easy for people who are newcomers to this world. I am, in fact, a newcomer to this world, so I found it really easy to get myself involved in Gluster. Now, if everything went the right way, our lab is replicated. but it's not vulnerable per se still. So let's destroy it. This, for everybody who's not into the container movement, or is the logic behind Docker or behind any microservice. You run, it fails. Okay, we respawn and we keep running. The main point in Gluster is to be recycled, to be constantly reissued, for saying it on a certain way. Okay, let's use GEVAUDAN to own Gluster. First, I want you to understand what the CVE is about. This is a new CVE. This is from May. I wrote this talk in June. And it was patched just I think 2 or 3 days after it was issued. It was a really silly bug. GEVAUDAN, Gluster Environment Vulnerable Authentication for Data Access and Nuke, is an exploit for GlusterFS CVE-2018 and 1112, written in Ruby. Basically, this vulnerability allows any Gluster client to connect without any authentication to a shared storage volume. In that shared storage volume, it's Gluster owned, resides the task scheduler. And by modifying that specific file from the scheduler, a cron file, I think we all know how cron works. Okay, it's a cron file. You can schedule arbitrary commands and tasks, wherever you like. This allows many actions from the privilege escalation to total data compromise or nuke. As you may see, this is using the tool DEFCON. It tells you what vulnerable packages you have and what are those vulnerabilities that reside in your system. As you may see, these are the only ones we have, Gluster, both from the client and from the server and from the common. In order to exploit this, the shared storage feature must be enabled. It is not enabled by default now. It was in the first versions. And it was vulnerable historically. So you should explicitly run in your server Gluster volume set all Gluster enable shared storage enable. We checked its status running Gluster volume get Gluster shared storage, Gluster enable shared storage. And then the snap scheduler should be enabled. It is a Python script, snap scheduler init. As you may see, this might seem like a complex configuration, but in fact, many enterprise sites already are using this. It might seem something complex for someone like me who doesn't use Gluster for something bigger than a simple proof of concept lab. But every environment, from medium and up, uses this feature. So, success. Here we see this, the option enable. We start the scheduler and says, okay, the snapshot scheduler is running, but it doesn't only cron snapshots. You can cron wherever you want. In fact, if you use any interface or even the command line, you can pass any arbitrary task. It doesn't have to be a snapshot. This feature, to this day, works like this. You can pass wherever you want. So what happens when I share the storage volume that is totally mint? It's intended to be shared. Its architecture of Gluster allows all clients to mount any volume, including the shared storage volume involved in this vulnerability. If at any point the Gluster snapshot scheduler is enabled, running that Python script we run, it will create a symlink in ets cron d, obviously owned by root. So anyone who can mount this can schedule cron jobs, again, passing wherever they want. This is the Red Hat advisory untouched. It's like they published it. As you may see, doing an ls-l, we see that it's a symlink to bar run Gluster snap cron tasks. So as I can interact with it, I could also attack it using only nano, B, beam, whatever you like. EE if you come from BSD, So, by issuing a given command, your lab is now vulnerable to GEVAUDAN. Okay, we'll use the exploit. The exploit, it's in fact something really simple. I wrote commenting it line by line, so any newcomer to the exploit writing world, I'm no expert at all, but if someone wants to start from a point, it's commented line by line so everybody understands what every line is doing at any time. You can easily, as I said before, try to hack this using your preferred text editor. But well, here we have the exploit. It comes as a standalone exploit, my preferred method, or as a metasploit module. In most cases, the standalone will be enough, and it takes just a few seconds to exploit this. This is the metasploit version. As you might see, it's further customizable than the standalone one. And in order to use GEVAUDAN standalone, you can simply run hem install colorize. Colorize is a gem for having a colored output. You can leave it outside if you want. And just sudo GEVAUDAN RB and the server you want to exploit. In my case, this one. It won't take more than 5 seconds and we'll schedule a new task, bin evil shell. You know, it's like a shell but evil. And it's fictional. And then we can check the contents of the tampered cron file. As you might see, it croned something to run. This output, this is a failure in the line breaking, but it's well croned. Okay. Now it's time to attack the Docker containers, and the result should be similar to this. This will be the output. GEVAUDAN. Okay, I am with superuser. Gluster mount binary located. That server replied to ICMP request. It's a simple request, nothing really forged or common. Gluster ports are open. We're attempting to exploit. We have exploited successfully the Gluster shared storage. We mounted it here. On the client side, this is automatic, so you don't have to set up anything unless you're using the Metasploit module. Okay, now we have access. This is everything we have in the volume. If you have any other compromising file, important file, whatever you have, it will be displayed here and will be fetched. The cron file was altered, and we injected enable Joe, or whatever you want to run. Okay. You can load the exploit at any time, check line by line, see how it works. The Metasploit module 2, it's not pushed into the Metasploit official repo. Okay. We'll take our time to explain this if anyone has any question. It's really simple, it's really easygoing, so it doesn't have any complexity behind running with superuser. There's a little patch we made. It's Castle, another standalone Ruby script. Why I took the time to build this? That seems really overkill. We have really big farms of servers running this vulnerable version on many clients. In fact, it's my first time pen testing Gluster at all. A customer told me, hey, Red Hat issued some advisory about Gluster. Okay. We used this with Ansible. You know Ansible? Like Chef or Puppet, but for poor mans like me. It worked. Telling us, okay, vulnerable option, or the snap cron task is assembling, can be exploited. So we have some report to show the customer. It's also in the repo. Also, you can find there the Docker file to build the image, some of these snapshots. Okay, how do I patch this? Like most vulnerabilities out there, the vendor issued its own patch. Simple update, upgrade, whatever you like. It's available across all platforms. Remember, Gluster is available from Windows to Linux, to even BSD. So everybody has its patch already running. Okay, my conclusions and questions. Gluster is not vulnerable per se. It's not something like Adobe Flash Player. In fact, in a span of 5 years, it had less than 10 vulnerabilities. In fact, it had 6. Two, the last two, are after Red Hat bought them. They were included before being bought by Red Hat, but Red Hat found them. And simple bugs like this can bring a great chaos. So, if you now feel like forking GEVAUDAN, modifying it, translating it, writing something else, be my guest. It's free to use. And it's a nice starting point for teaching someone to write an exploit step by step without having to learn assembler, C, or memory position, something that could be hard to newcomers and could scare them off. Okay, special thanks to the Data Duplication Village crew and to my working team. Anybody has any questions? Okay, thank you.